Welcome to the Algebra 1 Keystone Practice Exam 2019. As in the other video, I'm going to go through all the questions here for Module 1. If you have a question in particular you'd like to go to, feel free to fast forward to that part of the video. Otherwise, I'm going through each one as we go along. Let's take a look at our first question. Which expression can be simplified to the form 3 square root of y plus 3, where y is a positive integer? Keep in mind they're actually asking you to look like that. Now this seems a little confusing at first, but what they're really asking you to do is just simplify each of these radicals here. So I'm going to start with the square root of 18. If I were to simplify the square root of 18, I could split that up into the square root of 9 times the square root of 2. That would become 3 square root 2. Now what they're looking for is I've got the 3 out front. However, I could not change that 2 to be y plus 3, so it would equal 2 in some way that y would be a positive integer, because if I were to subtract 3, in order to make that work, y would have to be negative 1, and they're asking for y to be a positive integer. So that one doesn't work, so it is not A. Let's take a look at the next one, square root of 63. If I were to rewrite square root of 63, that's square root of 9, square root 7, which could go down to 3 square root 7. So again, I'm looking, can y plus 3 be written in a way where it would equal 7, and y would be a positive integer? And if I subtract 3 from each side, I find that here y could be 4. So I could rewrite that as 3 square root of 4 plus 3. Y is a positive integer, and therefore that would work. That would be my answer. Let me verify why the other ones don't work. Let's look at square root of 75. Square root of 75, well, if I were to rewrite that, that would be square root of 25 times square root of 3, and that would come out as 5 square root 3. It would not be a 3 out front, which is what I'm looking for. And my last one, square root of 84, well, that would go down to the square root of 4 square root of 21, and again, that would come out as 2 square root 21, and I'd have a 2 out front instead of the 3 that I'm looking for. And that's why those last two definitely do not work. So hopefully you were able to narrow it down to one of the first two. However, the first one I could not rewrite 2 in a form of y plus 3 where y was a positive number, and that's why it didn't work. In this case, our answer is B. Let's take a look at the next question. A dog's body temperature, T, in degrees Fahrenheit, F, is considered normal when the value of the expression below is no more than 0.75, and we have an absolute value expression there. A dog's body temperature is 101.2 degrees Fahrenheit. Based on the expression, which statement about the dog's body temperature is true? And it takes a look at a few different expressions, all right, since the normal body temperature is between, and it gives two values, all right, and then we consider it either normal or not normal. All right, that's the two parts to this problem. First, we have to consider this range that we're given right here. All right, in order to consider that range, we have to take a look at this statement right here, which is really an absolute value inequality. Let's break that down. Over here, I'm going to come in and I'm going to put my absolute value, which we said was the absolute value of T minus 101.75. All right, that's considered the normal body temperature as long as that is no more than, in other words, less than or equal to 0.75. All right, that's the inequality that they're giving us, and we can solve this inequality by taking the original one here. Oops, sorry. 101.75. All right, and not changing a thing, just keeping it just like that. And then I can rewrite the second one this time, keeping my T minus 101.75, but this time making everything else the opposite, greater than or equal to, negative 0.75. All right, at this point we can solve both of these. All right, I can add 101.75 to the side. All right, and I find that T is less than or equal to 102.5. All right, and on this side, I can add 101.75 as well. And I find that T is greater than or equal to 101. And so we get our range here, and we notice actually T is greater than this 101. That means this here is my minimum. All right, and T is less than 102.5. That means this here is my maximum. And so I could rewrite this compound inequality as 101 is less than or equal to T, which is less than or equal to 102.5. In other words, that's the range in between which our temperature must remain. Let's take a look at our options now. In our options, that option is shown here and here, making A and B false. But now let's consider, is this body temperature considered normal? So a dog's body temperature is 101.2. All right, so does 101.2 fall within this range? All right, well, it goes from 101 to 102.5, and therefore it falls within this range. Thus, the dog's body temperature is considered normal. And that's what we see here. So we've got our range from our absolute value inequality, which gave us a nice compound inequality. And then since the dog's body temperature fell within our desired range, within our solution region, it was a solution, and therefore it was considered normal. And that's number 2. Let's take a look at number 3. Over 1 week, a snack booth at the fair sold 362 cans of soft drinks for $1.75 each and 221 hot dogs for $2.35 each. Which calculation will give the closest estimate of the sales of the soft drinks and hot dogs? Now, again, this is an estimation problem. I recommend for an estimation problem that you always actually just do the values yourself. Don't estimate, just find the exact ones. If we were to do that, we would do 362 cans of soft drink times 175 per can, plus we'd take our 221 hot dogs times 235 per hot dog. And if you plug that into your calculator, you would get values of $633.50, plus we'd get $519.35. All right, but we really don't even have to go that far with what we're looking at here, all right? Because they're giving us a couple different options here to choose from of how we'd set this up, and we want to see how does this match up with these 4, all right? Well, if I were to look at this, I see that they're rounding our first ones to the hundreds. So let's round 362 to the hundreds. Since it's closer to 400, that would go up to 400, eliminating my first one right here. All right. And then we're looking at 175. That would round up to 2, as we can see that all of these are 400 times 2. All right. Look at our next one. All right, 221. Well, that is closer to 200, so that would round down to 200, causing me to eliminate this one here. And for 235, that's closer to $2, causing me to eliminate this one here, giving me my best option here is B. But you can always calculate B out to see if it does give you close to the exact value, which the exact cost, if we added that all together, would be $1,152.85. All right, good work. Let's take a look at number 4. When x cubed minus 2x squared minus 15x is factored completely, which expression is one of the factors? Well, without even looking at those options over here, I really could care less about these options. I'm just going to cross them out here for a moment. I want you to actually just factor it out. So let's take x cubed minus 2x squared minus 15x, and let's factor. And a big heads up, whenever you see a cubed in this class, it's likely going to be asking you to pull out a GCF. We always have to look for it, but if you have a cubed, there's most likely going to be a GCF of a variable. In Algebra 2, you'll see cubes where there's no GCF because they'll also have a constant on your expression. But in this case, there's an x that goes into all of them, so an x can come out as my GCF. There's no number that goes into all of them because my coefficient of the x cubed is only a 1. But if I were to pull out that x, that would leave me with x squared minus 2x minus 15. And now I can factor this expression further so that I can go down into 2 groups. And if you noticed, it is a just x squared here. That means it's going to start with just x and x. And we could just use the x of our diamond problem. All right. Now, if you don't remember that, you could always use your generic rectangle as well, putting your x squared bottom left, negative 15 top right, and 1 times negative 15 is negative 15. But the just x squared shortcut shows us that constant is my product. And as always, my coefficient of x there is my bottom piece. And what multiplies to get negative 15 but adds to get negative 2? Well, that's going to be negative 5 and positive 3. And if you remember our other shortcut aspect of a just x squared, these numbers would go straight into my group here, giving me x minus 5 and x plus 3. And that's because if I were to put them in here, as we'd normally do by putting in negative 5x and 3x, and I pull out my GCF, x would be pulled out here and here. Therefore, this must be negative 5 to make negative 5 times x negative 5x. All right? And this must be 3 here to make x times 3, 3x. And that's where our just x squared pulls out our shortcuts by just taking the numbers straight from your diamond problem and putting them straight into your groups. Now, with all that said and done, let's take a look over here at the left now and pick out one of our factors. All right, which one matches? Well, my first one does. X minus 5. That one's right here. None of the others match. All right, this one right here, they were trying to trick you right there, but that was not factored completely as they were asking for up top here. You need to make sure you factor completely, pulling out the GCF, and then continuing down into your groups. All right, good work. Let's take a look at number 5. A clothing company sells hats online to its customers. The price of each hat is P dollars. The shipping cost is S dollars. The equation shown below can be used to find the total cost C in dollars when N hats are purchased. Which equation can be used to find the price of each hat when 5 hats are purchased? The shipping cost is $6 and the total cost is $41. Basically, we are doing substitution, and they are giving us 3 values, 5 hats here, shipping cost of $6, and total cost of $41. Those are our 3 values, and they're asking us to plug them into our variables above. In order to do that, all you have to do is identify what each variable is, and here we see the price of each hat is P dollars. All right, so that's going to be our price per hat. We see our shipping cost is S dollars. All right, we see the total cost is C, and we see the number of hats purchased is N. All right, and that's what we're looking for here as we identify the different pieces. So let's look at what they gave us. First off, which equation can be used to find the price of hats when 5 hats are purchased? That's our number of hats. So 5 would go in for N, my number of hats. All right. The shipping cost is $6, so shipping cost is S, so that means that 6 is going to go in for S. And finally, the total cost being 41, well, they said the total cost is represented by the variable C, so that means 41 is going to go there. And what don't we know? Well, we don't know the price because we're using the equation to find the price. So the price is our unknown piece here. And if you look down below, you see that C is the one equation that puts all of those in the correct spot. Let's take a look at number 6. An equation and some of the steps used to solve the equation are shown below. One step is missing. Which set of statements is most likely the missing step and the property that justifies the step? All right, so let's take a look at what they have down here below. All right, we've got the associative property where they're just changing association there, which actually is a little bit illegal if you notice the way they did it. You can't just move the parenthesis here because I'm doing this 2 times the group. So I can't just swap that parenthesis because then the 2 is not being multiplied by that 3. So this is actually a wrong step to begin with. Let's take a look at the next one. The associative property on that one, well, they moved the 10x to the other side. That's not the associative property. What they did was the additive property of equality where they added a negative 10x to each side. All right, so that's not the associative property, making that one wrong. All right, it is an okay step to do, but just not the correct property associated with it. Let's take a look at C. C, they said they did the distributive property, and notice they did 2 times x, and now they have a 6, and on the other side they have a 15 and a 5x. Well, it actually looks like that is correct from doing the distributive property because that's what I would do first here to simplify. I would distribute the 2 to the group, giving me, a little ahead of myself, giving me 2x minus 6 plus 10x. And on the other side, I'd distribute the 5 to the group, giving me a 15 plus 5x. And that's exactly what they show here, which is why this is our answer. But let's make sure the last one does not work. The last one, they said the distributive property, but notice what they forgot to do. They only did the 2x and the 15. They forgot to do the 2 times 3 to get me 6 and the 5 times x to get me 5x. So therefore, these pieces here would be wrong, making that one wrong as well. And that's why our answer is C. All right, let's take a look at number 7. A student is selling small and large frozen pizzas for a school fundraiser. The student earns $3 for each small pizza sold and $4 for each large pizza sold. The student has sold exactly 30 pizzas. The student has earned $100. How many small pizzas and large pizzas has the student sold? Well, right away we're looking at a system of equations. How do I know that? Because I have 2 unknowns, the number of small pizzas and the number of large pizzas. And you could use any letters to represent those. I'm going to go with S and L to represent my small pizzas and my large pizzas. Now, with a system of equations, I have two variables, and therefore I need two equations. So I need to find two statements of equality, and I'm looking at this word has to help me identify that. Has is another word for is, was, were, and it all represents the symbol equals. So we know that 30 is going to equal something, and 100 is going to equal something. All right, so what does 30 equal? Well, 30 is the number of pizzas sold. Well, how could we find our total number of pizzas sold? Well, we can add the number of small pizzas, which is represented by S, plus the number of large pizzas, which is represented by L. Now, what's 100? 100 is the money sold. I can't just add my small and large pizzas to get the money. I have to look at how much each one was worth. And we're given that up here, $3 for each small pizza. That means the money from a small pizza would be represented by the expression 3S. All right, $4 for each large pizza means that the money from the large pizzas would be represented by the expression 4L. And if we add those two together, we will get our total money earned. And that's what we see there to get our system of equations. Now from here, you could, given these answers, you could just plug them in and see which ones actually work. You know, add them together to see which ones. It looks like all of them add together to get 30. And then you could plug in which ones would actually give you $100 from here. That's one way to go about it. Or you could just solve. All right, and I'm going to show you how to solve this just so that you can use that in the future and you can use the elimination method. Now, in order to solve this, I'm going to have to take this top equation and I'm going to multiply this top equation by -3. All right, that's going to put a -3 here in front of the S, which will make it the opposite of positive 3S. Now, make sure that you multiply everything by -3 as we do so. We're going to get this new result, and I'm going to put it up top right here. I'm going to put my original equation, 100 equals 3S plus 4L. And underneath of that, I'm going to get -90, -3S, and -3L. And I'm going to erase to make some room here, so I'm going to erase this piece of it. And now that I have one terms the exact opposite, I can line up my equal signs and I can add these to eliminate my S's. And that was the whole point, giving me 10 equals L. And at that point, I can see that the number of large pizzas was 10. And coming down here, I can see, all right, this one right here has the number of large pizzas that was 10. All right, so that one wouldn't work, this one wouldn't work, and that one wouldn't work. Now, if this is true, it's going to make both things true, so I got to make sure that this works in both of my equations. All right, knowing that these two add up to get 30 gives me that it was 30 total pizzas, so that works. All right, but let's test, will it actually give me the money that I'm looking for? All right, and I'm going to check that here. 20 times 3 plus 4 times 10. Does it give me 100? Well, 20 times 3 is 60, plus 4 times 10 is 40. And that does indeed equal 100. Therefore, my answer is correct, and my answer here is going to be D. All right, that's a system of equations. Let's take a look at our next question. Question 8. The system of equations below describes the relationship between the time t in seconds two objects have been traveling and each object's velocity v in feet per second. And we've got our two equations there. Based on the system of equations, which statement about the velocity of the objects is true? Before we get into all that, I actually just want to solve this to kind of understand a little bit more about what's going on here. All right, and if I'm looking at this, to solve the system of equations would really be asking, when will these velocities be the same? Because if -32t is equal to v, and that v is the same as -32t plus 16, I want to know when will the first velocity equal the second velocity. And if I go to solve that and I add my 32t to each side, something unique happens in this case. And that is that the t's completely drop out, giving me 0. On this other side, I'm left with 16. Well, when the variables drop out of an equation, we always ask ourselves, is this true? Well, in this case, is this true? Does 0 equal 16? No, 0 does not equal 16. 0 equals 0. This is a false statement, and therefore this will never be true. All right, and therefore we have no solution. All right, no value of t, in other words, no time in seconds that would allow our velocities to be equal. All right, and that's what we really see here in this situation, that there's no point in time when the velocities will be equal. All right, now from that, I want to go down and see what are the different options that they're giving us to choose from here to see which statement is actually true. Now let's look at number A, or letter A. The objects never travel at the same velocity. Well, hey, that one right there, that's exactly what we just said. We said the velocities will never be equal. They will never travel at the same velocity. And you might get confused because you could quickly look at this and go, oh, they both have a slope of negative 32. All right, but that's the change in velocity over time. All right, because we're always looking at our change in y over our change in x as our slope. In other words, our change in velocity over our change in time. So that's basically the acceleration or whatever that's happening to change our velocity. Our velocity is v, and the v's will never be equal, so the objects will never travel at the same velocity. The next one, the objects always travel at the same velocity. That one's false, but it's trying to get you into the trap of looking at the slope and thinking the slope represents our velocity here. V represents the velocity. So look at the next one. The objects travel at the same velocity only after they have been traveling for 1/4 of a second. Well, that would be if we solved this equation here and we found that t equal 1/4, but we found that t does not equal 1/4. And then the next one, so this one is also wrong. All right, and then our last one is pretty much the same thing. It says the objects travel at the same velocity only after they've been traveling for 1/2 second. So that one is also wrong. That's saying that if we solved this equation, we would have found t equal to 1/2. All right, but that is also not true because when we solve our system of equations here, we found that we got a untrue statement, which was a special case where there was no solutions. These two velocities are parallel and therefore will never be the same. All right, let's take a look at our next question. Question number 9. The solution set of an inequality is shown below, and they give us a nice little number line here. Which inequality has this solution set? Well, let's first identify what this solution set is. Notice that I have a compound inequality where I have my solution set x is in the middle, all right, and I've got myself, so this is our solutions, all right, and I have myself here a minimum value, which would be 3. And I have here a maximum value, which would be 6, my upper and lower boundary. And whenever we have a compound inequality with our solution set in the middle, we'll always use less than symbols, all right, showing that 3 is less than x, which is less than 6, because 3 is less than 6. If we look at the comparison just between 3 and 6, we can see that it has to be one of those symbols. And then we determine, can it equal either of those reference points? In this case, because it's an open circle, it cannot. So this is the solution set that we are looking for here. And I want to come down below and see which of these would get me there. And I can take a brief moment to solve them just to see which one gets me there. This first one, if I divide by 3, all right, I would do that on both sides here, dividing by 3, I would find that 1/3 is less than x, which is less than 2/3. It's not a. Look at the next one. To solve for x there, I would subtract 2. All right, and so what I do on one side, I must do on the rest. If I subtract 2 there, I'd find that -1 is less than x, which is less than 2, and that is not true either. All right, the next one, I could divide by 2. All right, so I divide by 2 everywhere. All right, in that case, I get 3 is less than x, which is less than 4.5. So that is not true either. We had the 3, but it didn't quite get us to where we wanted to be with our 6 up top there. And my last one, if I subtract 3 from both sides, I then see that 3 is less than x, which is less than 6. And that is the answer that we are looking for, and so I can do that. I do want to take a moment to remind you that you can actually plug these into your graphing calculator to see this number line here on the x-axis. And let me remind you how to do that. In your graphing calculator, you can go ahead and you can go to this y equals section, and it'll give you a nice little y1 equals. All right, and you can start to type in, and I'm only going to type in the last one just to verify it so that we can see what it would look like. All right, if you have a graphing calculator, I encourage you to do this at home or in school, wherever you're watching this video, because this is just a picture and you won't be able to see it exactly. But you can type it in, you can hit 6, and then you'll need that less than symbol. To find that less than symbol, it's actually here in our text option. And so you can press the second button and then math, and it'll bring up text. And there's this whole text keyboard, and at the bottom of the text keyboard, it'll have our little symbols, and I'm not going to get these in the right order here, but it does have all 4 of those. And then it has a nice little word done. Well, you can select the one that you want and then hit done, and it will pop it in right there. And then you can go ahead and you can press the X button, you can press +3, and then again go back to that text option and get me another symbol and put in 9. If you do that, all right, so if you do all of that there, and then you go to graph it, just going to erase that for a moment, and you go and hit graph, you're going to get a nice little coordinate grid here, all right, and you're going to get your little tick marks, all right, and you're going to see the solution set for this, which would be from 3 over to 6. And you'll see a little line that kind of looks like that. Mine's not perfect there, but you'll notice it gets to about 3 and it gets to about 6. And if you hit the trace option, it'll put a little cursor on there, and you can move back and forth, and you'll see the x value down here. And as you get to that reference point, that x value reference point will be around 3. And again, it'll be approximately 3. This reference point will be approximately 6. It'll be some crazy decimal because, again, you're dealing with pixels and you can't move perfectly on it. So just keep that in mind. But you can plug any compound inequality into our graphing calculators using the y equals and see what it would look like on the number line. It also helps us to know if you're solving one, which direction you can shade. Should you just want to check your work, I still encourage you, always work it out by hand first by solving our compound inequality as we saw, and then just use the calculator as a check step. All right, let's take a look at question number 10. Sandy has at least 2 times as many pencils as David has. David has 3 pencils more than Pietro, and Pietro has 4 pencils. Which number line shows the solution set for the possible number of pencils that Sandy has? Well, let's work through all of this together here. I'm just going to break down each sentence. I'm going to start off with Sandy has at least 2 times as many pencils as David has. So that means that Sandy has at least, which means more than or equal to 2 times David. All right, so that's her amount. I'm going to look at the next one. I'm going to switch my colors here. David has 3 pencils more than, so that's David has 3 more than Pietro. And then our last bit here says that Pietro has 4 pencils. So P equals 4. Now from here we can start putting things together. And if I know that P is 4, I can plug that in here. All right, to see that 3 plus 4 is 7, and I can find that D is equal to 7, allowing me to plug that in here, knowing that Sandy must be greater than or equal to twice 7, which in this case means that she must be greater than or equal to 14 pencils. All right, so which one of these shows a number line where a reference point is a solid circle at 14, and we are shading in this direction here to the right, everything greater? Well, this one here, I'm just going to start off with B here. That one's going the wrong direction, and D's going the wrong direction. All right, if I look at C, C is going over here. This is between 0 and 10, so that's about 2, 4, 5, so that's wrong. And I'm just going to look back at A. It was 12, 14, there it is right there, and my arrow is going this direction. So A is our best choice and our solution here in this case. Let's take a look at the next question. Question 11. The graph of the solution set for a system of inequalities is shown below. Which system of inequalities is represented by the graph? And if I scroll down, I can see my different options there. All right, and those are the 4 options that we have for our system of inequalities. And the problem is that none of them are solved for y. That means I can't just plug them into my graphing calculator. Now, you could take each one of these and you could solve them for y, and that is one way to go about it. All right, so I'm going to start off here, this first one. If I were to solve this for y, I'd end up adding 2x to both sides. All right, giving me y is less than or equal to 2x plus 4. All right, this one here, I'd have to subtract my 2x from each side. And then after I did that, I get 3y is less than or equal to negative 2x plus 6. I'd have to divide by 3 on both sides, and I would get y is less than or equal to negative 2/3 x plus 2. And you could do that for all of these, plug it into your graphing calculator, and then see which one matches. And you are definitely welcome to go ahead and do that. I'm going to show you an alternate route here to help you understand a little bit more about what a solution to a system of equations is really all about. And that is that I'm going to select a point inside my solution region. All right, so I'm going to pick a point, and I'm going to make it easy on myself. I'm going to pick a point on my x-axis. All right, because if I pick a point on my x-axis, and I'm just going to go for negative 4 here, All right. If I pick a point on my x-axis, that point should make both inequalities true. And that point is -4, 0, where x is -4 and y is 0. That's how I made it easy on myself. I made my y 0. If I could have, I would have picked 0, 0, but that is not inside my solution region. So that might help me eliminate one of these options, but not all of them. All right, so I'm going to pick with -4, 0. So I'm going to plug those in into my first one. -4 will go in here for x. All right, and this is just going to become 0. And I get 8. All right, -2 times -4 is going to be 8, which is less than or equal to 4. That is false, and therefore A is not it. It must make both inequalities true. I'm going to come to my next one over here. I'm going to see that -2 times -4 is going to give me 8. And so again, it's going to be 8 is greater than, sorry about that symbol, greater than or equal to 4. Well, that is true. Let's test it in the next one. 2 times -4. All right, that's going to give me a -8, which is greater than or equal to 6. Well, that is false. All right, so it is not B. And I move on to the next one. All right, once again, I notice this right here, -2x plus y is less than or equal to 4. It's the same as right here, so if it made it false once before, it's going to make it false again. And my last option is D, and we want to test out D to make sure that it works. And so I'm going to plug in, again, -2 times -4. That's going to be 8 is greater than or equal to 4. Again, I'm not concerning myself with y because y is 0. All right, and then 2 times -4 here is going to give me -8, which is less than or equal to 6. That is true. It makes both inequalities true, making D my final solution. And you could always verify that it is D. Again, if you want to plug it into your graphing calculator, I'll show you how you can do that for solving the correct answer here. We have -2x plus y is greater than or equal to 4. To solve for y there, I would just add my 2x to both sides and find that y is greater than or equal to 2x plus 4. And if I come over here, I see that that is a +4 right there, and I notice that this is going as a slope of up 2 over 1. Being greater, my shading is above, so that's that line right there. My second one, I've got 2x plus 3y is less than or equal to 6, and if I subtract my 2x from each side, and divide by 3, I find that y is less than or equal to -2/3 x plus 2. And we notice that this one does go through to here, and it's going at a rate of down 2 over 3. Down 2 over 3. And y is less than, so my shading is beneath that line, causing this to be my overlapping region. All right, let's take a look at our next question. Question 12. A teacher is buying word games and board games for his students. Each word game can be played by up to 4 students. Each board game can be played by up to 2 students. The teacher needs enough games for 30 students to play at the same time. The maximum amount that the teacher can spend on the games is $200. The number of word games X and the number of board games Y the teacher must buys must satisfy the system of linear inequalities below. So all of that information really is to give you these two equations to help you understand what they're all about. And the key to all of this information is not that you have to write the system of equations, but you have to identify which equation is talking about which restriction. All right, our two restrictions here come from the teacher needs enough games for 30 students. All right, and that's where we see this one right here, that the number of games must be more than 30 students, so that at least every student has a game and you have a little bit of extra. All right. The second restriction comes from here, that the maximum amount of money, that the teacher can spend on the games is $200. That means this is going to be the cost of the games, and we need to keep that under our $200 budget limit. All right. So that's what you're looking at. That's these two restrictions here as we continue to look at this question. All right. Then it says, the teacher plans to buy 5 word games and 8 board games. Which statement about the number of games the teacher plans to buy is true? Now, before I look at all of these statements, I want to actually take a moment and plug these in. So 5 word games, that is x, because x was the number of word games. I'm going to plug that in here. And I'm going to take the 8 board games. Board games is represented by y. And I'm going to plug that in as well. So let's start off with the first one. I'm just going to plug in 4 times 5 plus 2 times 8. And we're going to check, is it greater than or equal to 30? And if you take a moment and plug that in, you find out that the result is 36. And that is greater than or equal to 30. And therefore, it makes the first thing true. In other words, we'll have 36 total games, which is more than enough for our 30 students. So it satisfies our first inequality. Let's look at the next inequality. If we take the 14.5 times our number of word games, 5, and we add it to 18 times the number of board games, 8, did we stay underneath our $200 limit? And if we do that and plug it in, we find that we get $216.50. So it's going to be $216.50, and that is not less than or equal to our $200 limit. In fact, we went over by $16.50. Now that we know that information, all right, let's go ahead and let's see which of the following statements is true. Let's look at A. There will be enough board games for the 30 students to play at the same time, but the total cost will be greater than the maximum amount. Well, that's our answer right there. All right. I'm going to go further to make sure that the other ones are not true, because you always want to double check that the one you choose is true and the rest are not, to verify that you did indeed pick the right one. But in this case here, that's exactly what we just said. We said that there's enough games because we have 36 games and we needed at least 30, but the total cost here is more than our allowed limit of $200. Let's look at B. There will be enough games for 30 students to play at the same time, and the total cost will be less than the maximum amount. That's wrong. It's not less than the maximum amount, so B is false. There will not be enough games for the 30 students. Well, that is not true. There are going to be enough games for the 30 students. And the last one, there will not be enough games. So again, that one is also false. And so we see that A is the only one that is true in this case that satisfies the relationship that we're looking for. All right, let's take a look at our next question. Question 13, our first of our constructed response items. In a science experiment, a scientist records the wavelengths of 6 waves. The wavelengths in nanometers are listed below, and we have a list of our numbers in various form. They appear to all be rational numbers in some regard. All right, which 2 wavelengths are equal to one another? Well, in order to compare which ones are equal, we've got them in various forms, and what we need to do is we just want to convert them all to decimal. I mean, you could convert them all to fraction if you want, but I really think going to decimal is the easiest route to really compare them. Our first one is already done, so I'm just going to box that one out. Our second one, if we divide that out, 5 divided by 100 is going to give us 5 hundredths, in other words, 0.05, and that's going to be our decimal value there. 10 to the negative third, we'd start to get into the negative exponents or scientific notation format a little bit, and we know that that's going to move our decimal. All right, this one's going to be 0.1, 2, 3 places behind that decimal. All right, and it is 1 because technically this is 1 times 10 to the negative third, if you think about it, because 1 times anything is itself. It's the identity property of multiplication. All right, the next one's already a decimal, so we could just mark that out. 1/1000th, if we're going to convert that to a decimal, that is in the thousandths place right there. All right, and our last one, scientific notation, we're going to move that decimal, all right, 2 places to the left, giving me 0.02. Now, which one of these are the exact same? Well, it appears that this one right here, 10 to the negative third, and this one right here, 1/1000, are the same. So we would write this as 10 to the negative third, as they ask you to right here. And we'd write this one as 1/1000. All right, those are our 2 that are the same and equal to each other in this case. Let's take a look at part B. In a science experiment, it gives all the same things. I'm not going to read through that again, but this time part B says, which wavelength is the shortest? Well, again, I want that decimal form. Let me just put these back up here for you so that we can compare them. All right, I'm going to put all the decimal values back up there. Oops, sorry for that last one. Going a little fast. All right, now we're looking at all our decimal values. I can definitely mark this one out because that is greater than 1. All the rest are less than 1. All right, and notice the more zeros I have between the decimal and my first significant digit, in other words, my first non-zero digit, is going to make my number smaller. So this only has 1 0 before it gets to the 5. This only has 1 0 before it gets to the 5. These have 2 zeros before they get to the 1, but this one right here has 3 zeros before it gets to the 1. This is our smallest decimal value. Our shortest wavelength would be 0.0001. All right, and that's what we're looking at there. All right, that's 1/10,000th as we're looking at it. So that is our shortest wavelength for part B. Let's go on to the next part of this constructed response item. All right, part C. To find the speed of a wave, the scientist uses the formula shown below. The wave with a wavelength of 10 to the negative third nanometer has a frequency of 10 to the x. The speed of the wave is 10 to the y, where y is greater than 3. Write an inequality in terms of x to represent all the possible values of x. All right, so just taking a look at this, it seems complex, but really we're doing simple substitution, and then we're applying our laws of exponents. Let's look at the substitution piece first. It says the wave with a wavelength of 10 to the negative 3. All right, that is our wavelength, so I'm putting in 10 to the negative third here, times our frequency of 10 to the x. We're putting in 10 to the x here. We're substituting for our frequency. And the speed, all right, says the speed of the wave is 10 to the y, so that's going in right here, 10 to the y. All right, and if we look at this, all right, we see we have a multiplication problem dealing with terms that have the same base but different exponents. And if we remind ourselves how to do that, if I have x to the a, all right, times x to the b, it will equal x to the a plus b. Therefore, in this case, if these are going to be equal, we're really seeing when we look at our variables, we're going to end up having 10, and the y is going to equal negative 3 plus x. Well, in this case here, they're saying we don't want y to be equal. We want y to be greater than 3. Well, if y is negative 3 plus x, then what we're really saying here, if I want y to be greater than 3, and I'm saying that y is negative 3 plus x, then what I'm really saying is negative 3 plus x must be greater than 3. And that's an inequality that I can write to represent all the possible values of x. And to get more specific on the possible values of x, I would actually solve this adding 3 to both sides, realizing that x could be greater than 6. X can be any value that is greater than, not equal to, but greater than 6. And I could write that inequality down here. X is greater than 6. That would give me all the possible values of x that would make this statement true, where y is greater than 3. Let's take a look at part D, the last part of this constructed response item. The wavelength of a 7th wave is recorded. The wavelength is greater than 2 times 10 to the negative second nanometer and less than 5/100ths nanometer. Write a possible wavelength in nanometers for a 7th wavelength. Write the possible wavelength as a fraction with a denominator of 100. Remember that a fraction is defined as a over b, where a and b are integers, and in this case, b is equal to 100. So what we're really looking for here that we're going to put into our answer is x over 100, and we got to find out what is this x. Now, the restrictions that we have on x are this. We know that it's greater than this number right here, but that number is not in a fraction and it's not over 100. So let's get it there because it's going to be easier to deal with. We said earlier that it could be written as a decimal like this, using scientific notation to convert that back to standard notation. Well, that's 2/100ths, all right? And I can write that as 2 over 100. And that means I want my value to be greater than this value of x over 100 to be greater than 2/100ths, but I want it to be less than 5/100ths. All right, now you might look at that and you might see what numbers could be x at this point, but just in case you can't, I'm going to go ahead and simplify or solve this for x by getting rid of that 100. I'm going to multiply everything by 100 in this case, just to cross out my hundreds here so that you can see more clearly the values of x that are allowed. And we get 2, and I'm just going to draw this over here to the right. All right, we get 2 is less than x, which is less than 5, which means that x can be any integer between 2 and 5. Well, what are the integers between 2 and 5? 3 or 4. That means our values that we could put down below here, we could do 3 hundredths or we could do 4 hundredths. All right, and those are the two things that we're looking for. Now, technically, you could write any other fraction that would get into, like, there are a lot of other fractions that could be in between here. All right, but in this case, they were asking specifically for a denominator of 100, and that's why we're sticking with just the 3 or the 4 as we put those in. So one of those would work, and you could plug that in as 3/100. All right, and that's our constructed response item for number 13. Taking a look at our next constructed response item, number 14. 4 people each deliver food to people's homes. Curtis charges a flat fee of $2.50 for each delivery, plus 20 cents per mile for each mile he drives. For one delivery, Curtis drives 6 miles. How much does Curtis charge to deliver the food? I'm actually going to start with this second piece down here where it says write a linear equation in slope-intercept form to represent this situation. Because if I have that linear equation, then it's going to help me out. Let me remind you that our linear equations can be written in the format y equals mx plus b. All right, and you can always look to your formula sheet to see that. We see here that he does $2.50 for each delivery, and I know that it says for each, but that's really, we're talking about one delivery here, so that's our flat fee right here of $2.50. All right, our 20 cents per mile is really the slope that we're looking at. So our equation that we'd like to write here is y equals 20 cents times x plus a fee of $2.50. And here we're going to be driving for 6 miles, x being our number of miles. And so we could come here and we could plug in y equals 20 cents times 6 plus $2.50. All right. And if we do that, we could boil this all down using our calculators to $3.70. And that's what the charge would be here. So it would be $3.70 that Curtis charges to deliver the food. All right, let's take a look at the next part of this, part B. Audrey charges a flat fee of $4 for each delivery plus a certain amount in dollars per mile for each mile she drives. For a distance of 30 miles, Curtis and Audrey charge the same amount. How much does Audrey charge in dollars per mile? Show or explain all your work. All right, well, first off, let's remind ourselves what Curtis is doing. I'm going to say Curtis here. He was 20 cents per mile plus $2.50. All right, and Audrey here would be y equals an unknown amount. We'll say mx, plus she has an initial rate of $4. And we're saying that when x equals 30, then the y's will equal each other. In other words, when 0.20 times 30 plus 250 is applied here, then we will get the same thing as m times 30 plus 4. And that's something that we can then just solve as we go to solve this here for x. And as we go about it, on the left-hand side, we can just put that all together. We can go 0.2 times 30 plus 2.5, and we get $8.50. And that's equal to 30m. I'm just going to rewrite that as we might normally see our variable. And we can subtract 4 from each side, giving me 450 is equal to 30m. And then we can divide that 450 by 30, which then, if I do that on both sides, sorry that I'm going into our text there, but it all works out, and we can see that it's going to be 15 cents for our slope. So she is charging a total of 15 cents per mile there as a result. And when they say show or explain all your work, I just showed all my work, or you could verbally explain that. Here, I'm just looking for you to put in the 15 cents for this actual sheet here. All right, let's take a look at the next part, part C. The amounts of money Peter and Maria each charge to deliver food are described below. Peter charges a flat fee of $3.75 for each delivery plus 10 cents per mile for each mile he drives. Maria charges a flat fee of $2.25 for each delivery plus 25 cents per mile for each mile she drives. And before I go to the rest, I'm just going to write those equations real quick. This would be y equals 10 cents times x plus the initial fee of $3.75. And this equation would be 25 cents as our slope, all right, per x plus an initial fee of $2.25. That's a 5 right there. All right. Peter says that there are two distances for which he and Maria charge the same amount. To prove Peter is not correct, Maria graphs a line for her delivery charges and a line for Peter's delivery charges. Each line represents the relationship between the amount y in dollars each person charges for delivery and the distance x in miles each drives for the delivery. Without showing the graph, explain how Maria's graphs of the two lines proves Peter is not correct. Well, without going into the graph to show that these are both lines, how do you know they're both lines? They both have a constant rate. So as you go to explain this here, both of these have a constant rate, and therefore they are lines first. And lines have a series of 3 different relationships. You can have 2 lines that intersect at a given point. You can have 2 lines that are parallel and will never intersect. This would be same slope, but different y-intercept. Or you could have 2 lines that are the exact same line, so it would appear as though it's just one, and that would be same slope and same y-intercept. All right. In this case here, we can see that they have different y-intercepts, so we know that they are not the same line. And on top of that, we can see that they are different slopes. That means that these will be intersecting lines. And lines can only cross at one point if they do intersect. And therefore, there could only be one point at which they have the same amount. And that's what you're really getting at here. Without going into the graph, talking more about the equations and identifying that the slopes are different and the y-intercepts are different. All right, that's what leads us to see here these are not the same line and therefore will be intersecting. Even if the y-intercepts were the same, that would be okay. As long as the slopes are different, that y-intercept would then be the intersection point. As long as the slopes are different, the 2 lines will cross only once. And that's what we're really looking for here in our explanation. All right, and that is the end of Module 1. All right, I hope you do well, and good luck.